question is, can that happen? Right? So how can we ensure that this is not possible? So the way this would be, so the way I try to explain this to you would essentially be, right? So you have one block which contains the transaction, and what you can do is, if you can try to, create the pretense that there's an alternative reality where, where the transaction has never occurred, then you would have the ability to steal the money. Now, in order to explain why this is not possible, I first need to explain one concept, which is the way how the blocks are being built. And there's a fundamental rule in there, or convention that people use, which is the so-called longest chain rule. That is that the network as a whole accepts only the transactions that are part of the blockchain, which is the longest. Now you go, okay, so let's go with that convention. Let's say it's there. But let's say something happened, right? You have a situation where by accident 2 blocks are created at the same time. Let's just go with that, right? Now, why could this happen? Well, it could be happening by latency, right? So a mining farm, a miner somewhere in China may have created the block B4, and then a mining farm somewhere in Iceland has created at about the same time the block B3, and they both broadcast. I'm not saying at the same time, but the world is big and data needs time to travel. So it could, take, because of the latencies, it's possible that different parts of the world hear about each of these blocks at different times. So you have a situation where there's 2 blocks possible. Now let's go and that is something which can happen, which actually happens all the time and can happen all the time. In particular, actually, if blocks get created very, very frequently, then that's certainly something that occurs. So now let's say, for the sake of the argument, the block B4 finds somebody who wants to support B4 and builds a block B5 on block B4. And there's also somebody who has a block B6, which builds on block B5. So effectively, there's a fork, right? There's a short fork with a block B3, and there's a longer piece of the chain which has the block B6 in it. Now you are somebody who wants to have another block B7, okay? So first, this is just what it is, right? So you have a block B7 now. So where would you want to put it? Now you could add it to B3, or you can add it to B6. Now you know that the convention is that the longest chain may win. You also know, and this is something which is sort of like in the back of your head, is you're unlikely to create actually the block thereafter and thereafter. So this is like a one-time thing. The next time it's going to happen, because there's a high degree of randomness in there, you will not be, with very large probability, you will not be the one creating the next block. That's it, okay? So now suppose you would put it to block B3. Then the lower chain is still longer. So the next block is still supposed to go to block B6. Right? And because they have no idea why you want to do what you do, they just see the longest chain, so they will go to block B6. Now, why is that a problem for you? Well, if the chain goes to block B6 and the next one would go to, again to the same chain because it's now even longer, and so on and so forth, you having added to block B5 is the same as your transaction never having occurred, because the chain will not accept your transactions of actually ever having happened. So the implication here is what you would do for you is you would lose your Coinbase reward for the block. So you have an incentive to add it, in fact, to the longest chain, if this is the convention that people do. And there is, in fact, research out there. There's 2 papers, one a computer science paper in 2016, and then one finance paper in 2018 that both say the same thing, is that indeed the longest chain is a Nash equilibrium. Although, of course, there's other equilibria that could occur, because it's really repeated game, long story. But there's different games that could occur. But the important part is this is actually an equilibrium.